In this video, we'd also like to explore how our Z slash probability table and also our electronic means of Google Sheets can be used to solve for different aspects of normal distribution curves. So this time, in example 5, we're going to be asked to find the value of x along this axis that is going to result in having a probability of 0.8888. So from the description here, we can see that the mean is 10 and the variance is 2.25, so therefore the standard deviation is the square root of that, which makes it equal to 1.5. So just to give you, again, a visual of what this question's asking, if we were to go over 3 standard deviations in both directions from the mean, we're looking at 11.5 here, and another 1.5 would be 13, and 14.5, and then subtracting in this direction would give us 8.5, 6, and 4.5. So again, what's the question asking? It's saying what value of x along here is going to result in a curve area of almost 88-90%. So we're going to expect something to be pretty high up in this region, right? Somewhere in here. So we know that it's going to be between these two standard deviations somewhere. So first way that we can do it is using tables, and I'm going to show you how that works. So I like to call this a reverse lookup. Kind of like if you go on to reverse lookup 411 on the computer, if you get a call from a number you don't recognize, you can punch in that number and see if it can locate who it might be. If it's an unlisted number, that doesn't work, but sometimes you can actually see who called you. Maybe it's someone who's not in your contacts, but it is someone you know. This is similar. What we're going to do is we're going to look for a probability of 0.8888 somewhere on this table, and use reverse lookup to see what its Z value would be. I'm actually going to put the words reverse lookup in your notes so you know what I mean by that. To discover that, Z equals. All right, so let's try this. So the one thing I notice on this table is the left side of the table has probabilities that start almost at a value of 0 because it's so far to this side of the curve. Our negative Z values are always to the left side of the mean, and then these are to the right side of the mean, by the way, if you haven't made that connection yet. And we notice that it ends around 0.46. So, and up here around 0.5, okay? So we're getting bigger. We're getting to a value between 0.5 and 1, or 0 and 0.5 here. So we're going to skim and scan and read this like a book, because you'll notice that the values are increasing as you read it line by line, until we discover, bam, 0.8888 right here. So I'm going to use my sticky notes to help me read the Z value off of that. And I read the Z value as being 1.22. So we can put that in right here. Now, why is this useful? Well, because we know that Z is kind of like the bridge between an x value and its probability or its area under the curve. And that relationship between Z and x is this, right? Z is equal to the mean minus, or sorry, the x value minus the mean over the standard deviation. So at this point, we're trying to solve for x, and we know the other 3 values. Let's sub them in and do this. So the Z value is 1.22. We don't know x, but our mean for this one is 10, and our standard deviation is 1.5. So as I unpack all of the operations that are around x to get it by itself, I have to use SAMDEB, or anyway, opposite operations. So in order to get rid of divide by 1.5, I'm going to have to multiply both sides by 1.5. And when I do that, that's just going to leave x minus 10 on the right. To get rid of this minus 10, I will need to add 10 to both sides. So X is equal to 1.55 times 1.22 plus 10. And that comes out to 11.83. And that makes sense, right? We knew that this X value to have an area under the curve of 0.888 had to be somewhere in this region, so that's reasonable. Now, how would we do this using Google Sheets? We have to know how to program it in order to find X instead of to find the probability. And the good news is it's pretty easy. The general formula for doing the reverse lookup, if you will, is this. It's equals, again, you would punch this into any cell of Google Sheets, norm INV, so normal distribution inverse, or in my words, reverse lookup. And the first thing that you punch in is the probability for the X value you're trying to find. Then you punch in the mean, and then finally the standard deviation value. And the good news is there's only 3 things to punch in doing the reverse lookup, whereas before, when we were solving probability, we always had 4 things. We had to end with that word true. Okay? So for this example, I would punch into a cell of Google Sheets, norm INV, and my probability is 0.8888, my mean is 10, my standard deviation is 1.5. And I encourage you to pause, stop, and try it to make sure that you can use Google Sheets effectively this way, because it's pretty slick. When you hit enter, you should end up with, not surprisingly, that X is equal to 11.3, the exact same as if we used the table method. All right, we have one final example that's I'm going to use this programming as well in Google Sheets. And the one thing that you may have noticed in a lot of the examples in this lesson is they haven't really been real life. They've just been sort of, here's some numbers with respect to the distribution, let's play. So let's end this lesson with a real life example per se, example 6. Let's look at some data with respect to the height of Canadian males. Let's make the assumption that the mean height of a Canadian male is 181 centimeters and that the standard deviation is 4.3 and that the heights of Canadian males fit a normal distribution. So our first question is, if you are taller, 190 centimeters or taller, what's the probability someone is taller than you picked at random? What I'd like to do is actually sort of draw a picture of what this looks like quick first, just to give you the visual of the math that we're doing. Okay, so our random variable X this time has units of centimeters because it is heights of Canadian males, and we can put our mean value of 181 here. And what we could do is we could also label up to 3 standard deviations to the right and the left as well by adding 4.3 3 times and subtracting 4.3 3 times. So I'm going to add in some little markings to indicate that, and I'm going to label their values this way. So this one would be 185.3. I'm just going to stagger them because it's a little bit squishy. 189.6, and the third standard deviation would be at 193.9. Going the other direction, I would have subtracting 4.3 to give 176.7. Another 4.3 subtracted would be 172.4, and then that last standard deviation away from the mean would be 168.1. Okay? So this question's saying, if you are 190 centimeters, so I'll put it just after this one, or taller, what's the probability someone's going to be taller than you? And we're going to expect it's going to be a pretty small percentage. Okay, so I'm going to go straight to, I'll use tables first, and then we'll also show how you would put it into Google Sheets. So with the tables, what I need to do, of course, is take the entire, actually, you know what? I'm not going to do tables for this one. We'll do it in part B instead. Let's go straight to Google Sheets. So in Google Sheets, my probability for a Canadian male being equal to or taller than 190 would be the entire curve minus the white section. So 1 minus, and I would punch in norm dist. Just going to wrap around to here, sorry about that. So we have 190 as our x value, we have 181 as the mean, 4.3 as the standard deviation, and then we have to add that word true in there in the programming. Okay, try it. When you hit enter in Google Sheets, in that cell you should see a number that looks like this when rounded to 4 decimal places. If we wanted to make it a percentage, it'd be about 1.8%. Okay, there we go. And we expect it was going to be a small percentage anyway based on the visual we can see for this scenario. Now for part B, I'm going to use the same graph, and it says here, between what two heights are 68% of Canadian males? We're going to try and use tables and sheets. So 68% using tables, I want to give you a visual first. I'd also like to consider this curve not just having an area of 1, but having an area of 100%. And if that's true, then our median represents 50% because of the symmetry of this curve. So if we want 68% of males to fit under this curve, we don't want it shifted one way or the other. We want it to be symmetrical about the mean. So if I want 68% to be split across, half of it, 34%, will go to the right of the mean, and the other 34% will go to the left of the mean. So that means my upper threshold here would be 50 plus 34, which would be 84%. And the bottom threshold for the shorter end of those Canadian males would be 50 minus 34%, which would be 16%. Okay? So again, I'm going to have to use reverse lookup because I've got the probabilities or the percentages for the areas. I want to know what the z values are so I can see what x value it corresponds to. So what I want to do is I want to look up 0.16 and I want to look up 0.84, reverse lookup to find the z value that corresponds with each of those. So let's do that. So 0.16 will be on this side, and if I, again, read it like a book until I get to 0.16, let's see. There's 166.6258, so it's going to be somewhere in here. Am I doing that right? Let's see. Oh, 0.016, that's right. So 0.16, sorry about that, would be, oh, I've gone past it. Let's see. 161. Oh, here we go. 161 is right there. Okay, at the far end, right there. And 163 is here. That's the closest I'm going to get to being 0.16. So I'm going to use, for a z value, negative 0.99. I'm going to do the same thing for 0.84. So again, I'm not looking down the gray parts here for z. I'm looking for the probability. 0.84. It's going to be on the right somewhere. So 0.84, here we go. 0.8413, 84138. Looks like this one's going to be the closest right here, because in the previous line I only get to 81. So looks like my z value is going to be 1.00. So let's do that. So then we can use this equation of z equals x minus mu over standard deviation to solve for x in both of these scenarios. I'm going to fast track and not take you through the individual maths because we did an example of that previously, but moral of the story down here is that x comes out to 176.7 and x here comes out to 185.3. And you should check that you can do that. Don't just take my word for it. Okay? So there you go. 68% of males fall between the heights of 176.7 centimeters and 185.3 centimeters. So this is how we use tables to determine that. Could we use Google Sheets to do it? Absolutely. So Google Sheets, we would need to find out what the x value is for the lower and which the x value is for the upper. And again, this is using that inverse function. So for the x lower, we would punch into the spreadsheet equals norm inverse. Let's put in that percentage, which is 16. We'll do it as a decimal. The mean is 181, standard deviation is 4.3. And again, we only need 3 things to input when we're using this function instead of 4 when we're using norm distribution. And when you hit equals, it should end up giving you, not surprisingly, a value of 176.7, which is what we got over here using this method. If you do x upper, again, you would punch in equals norm inverse. And again, you would not punch in, just as a reminder, this would not get punched into the cell. I'm just showing you what I'm calculating here. Okay. Norm inverse, let's do 84% this time, 0.84. 181 and 4.3. And when you hit enter, guess what? 185.3, which is the exact same as this method here. Now there is one other method that we could use in this very special example that I want to show you too. You'll notice that it said 68% of males, right, have to fit within what range? You may recall from one of our earlier lessons that if we go one standard deviation over, or another, in both directions, we had some special probabilities that went with each of those. You may remember that one standard deviation on either side of the mean resulted in 68% of all data points being within that range. The next one was 95 and then 99.7. So what we could do, because it said 68, and we could not do this if it didn't say 68, we'd have to use one of these other methods instead, is we could simply add a standard deviation to the mean and subtract one to get the lower and upper range. Well, you know what? We've already done that. We did that at the very beginning of the lesson. There they are. Darn, I was sneaky. We wouldn't have had to do all this work, but now you know. So there you have it. Some more ways to use Google Sheets to solve a variety of problems for normal distributions. If you have any questions, don't hesitate to ask.